Hi guys, this is the video for the 3.3, 3.4 notes, and we're going to focus on writing equations of lines and linear functions in this section. I am recording this in my classroom, and the class next door is super loud right now, so hopefully they won't disturb us too much. One of my students, Jessica, begged me to work very hard to get this video done because it was very loud in our class as well today, and she likes to watch the videos. So the learning objectives of this section are to write equations of lines. Last week we looked at the slope of lines. We looked at the slope, how to read the slope off a graph. We also looked at whether to determine lines being parallel or perpendicular from the slope. And we also looked at why the slopes of perpendicular lines are negative reciprocals of each other by rotating points on the lines. So that was last time. We're going to review a little bit of that slope again, but then mainly focus on writing equations. And we're going to write equations when given certain information, either a graph, slope and intercept, or we could have the x and y intercepts, both of them, or two ordered pairs. We're also going to look at equations of lines in the slope-intercept form, as well as something called the point-slope form. And you can get away without knowing this, but going forward, this point-slope I'm starting to learn is actually pretty convenient for some applications. Okay, so the slope is, as we talked about last week, it's a number. So it's a numerical constant, meaning unchanging. It doesn't have a variable in it, and specifically it's a ratio, rise over the run. Sorry about my mess of writing. And it's really trying to show numerically how steep or how flat a line is, and the sign of the slope is describing whether the line is going up and to the right or down and to the right. So in this case, in my diagram over here, I have a positive slope, but if we were actually going downhill, left to right, then it would be a negative slope. So we talked about slope. We used the letter M for it. We talked about y, that is, last week. And the slope is the rise over the run. And we also talked about the rise. Some of your middle school teachers did talk about delta. This is a Greek letter here, delta. And delta, we just use it as mathematician shorthand to stand for the change of, or the change between. So the change of the y over the change of the x, that's how we numerically describe that rise over run. So in my diagram over here, it would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if I had an example here, maybe I'm just going to make up some numbers here. If x sub 2 is at 10 and 5/10, and y sub 2, I'm going to say 7, and let's say x sub 1 is 3 and y sub 1 is 2, then if I wanted to find the slope, I would say my rise is the change between the y coordinate. So be careful. I almost always want to start writing 10.5. But we're looking at the change of y, so I would say 7 minus 2 over 10.5 minus 3. 7 minus 2 is 5. 10.5 minus 3 would be 7 and 5/10, or 7.5. Now this is awkward. So although I'm not totally fixated or obsessed with you reducing your slope, in this case, I would like you to clean this up a little bit. I don't want to see a decimal in the numerator and denominator. So a quick way to rewrite this would be multiply both sides by 2 to get 10 over, let's say, 15. That is a 0, by the way. That's messy. Sorry, I don't like it. I've got to erase. So here we've got 10 over 15. And we did that by just multiplying by 2. Top and bottom. And if you want to reduce 10 over 15 to 5 over 3, even better. But I really don't want to see the decimal in the ratio. A ratio, really, just to finish the thought, a ratio is a number over a number where b does not equal 0. So let's try to clean it up a little bit. Last week we talked about parallel lines. and we showed how parallel lines have the same slope. So in this case, on this line I have a rise of 2, a run of 5, same thing down here, 2 and 5. So we have slope of 2/5, and if I called this line L and this line M, I could conclude L is parallel to M because they have the same slope. Likewise, we focused on the relationship between slopes of perpendicular lines last week and y. So I'm not going to go too into detail with that. But in this case, we have a blue line here. Each unit here on the grid is a half. So we have 4 and 4. So we have a slope here on the blue of 4/4, which equals 1. And on the red here, it's a negative, down 4/4. So we have a slope of negative 4/4, which is negative 1. 1 and negative 1 are opposite reciprocals of each other. So if I called this line, let's say P, and this line S, I would say P is perpendicular to S. And also just remind yourself that the slopes have opposite reciprocals of each other. Okay, just remember that. Okay, X and Y intercepts are the location, and we describe location on real number lines with a number, 1-to-1 correspondence, where this line or this function intersects the axes. And if you don't like the word intersects, I guess you could say crosses the axes. That's an S and that's an E. Axes, plural, is spelled with ES, whereas a singular would be AXIS. So here, the y-intercept happens anywhere on that y-axis, and we would describe that with some kind of dependent variable y, dependent on the value of x. But we do know that wherever that intercept happens, x equals 0. Y could be a variety of values, but x is always going to be equal to 0. Why is that? Because everywhere on this axis, x is not positive, x is not negative, x is 0, everywhere on that line. Likewise, the x-intercept happens where it intersects the x-axis, and it could happen anywhere, infinite number of points on the x-axis. But we do know, and that's why, by the way, we have this independent variable placeholder here. But we do know that wherever it happens, y equals 0. We know that because everywhere on this axis here, y is not positive, y is not negative, y is 0 on that line. So often we do have to solve for these. The y-intercept, we often have to solve for by substituting in an ordered pair that we know is on the line and solving for that y-intercept. And often the x-intercept is not right on the grid. It may be a decimal. And so to really get accuracy with it, we would have to substitute y equals 0 into the function and solve for that. All right, let's talk about the formats of line equations. So the first one that most people are less familiar with is the point-slope form. And it's pretty easy to find out how to get it. We know, we talked about on the previous page, that the slope is the rise over the run, and the rise is the difference between the y coordinates between 2 points, and the run is the difference between the x coordinates. Well, let's take a look at this in more detail here. I'm just going to rewrite it, try to write a little bit more clear. If I wanted to cross multiply here, I can get 1 times the difference between the y coordinates is just that difference. And then on the other side, m times the difference between the x coordinates. So if I'm going to multiply the slope by that difference, I've got to put that difference inside parentheses. And so you can see right here where that point slope comes from, okay? The only difference that we have in the formula is we don't want to drop our dependent and independent variables. So I'm just going to rewrite that as y minus y1 times the slope of x minus x1. Wow, they're playing a very loud movie next door. Okay, so here you can see we can use this formula. You can see where it comes from. It just comes from the slope. So in our example here, if we set up here that the slope was equal to negative, whoops, I need an E, equal to negative 2, and we know 1 point on that line, we're told 1 point is 3, 5. Well, that is x1, and this is y1. So we could just substitute that in. Y minus 5 equals, slope is negative 2, x minus 3. And that's our formula. Now, I know most of you have, totally used y equals mx plus b. We'll talk about that in a minute, for several years now. But this is fine. I mean, you could rearrange this and get it into y equals mx plus b if you wanted to. But there is a reason why this actually becomes convenient, and we'll talk about that in the next section. All right, most of you are more familiar with this. So y equals mx plus b. And you know that this m is the slope and b is the y-intercept. Why is that the y-intercept? Well, we know that the y-intercept happens when x equals 0. So if this is 0, this whole term just falls out. That's why that pure constant here, this number, is the y-intercept. And I think I misspelled intercept. I need a P in here. Okay, so this is what we're most familiar with, and it's very convenient to use. And if you want to, you really can do everything that you need to do with this, and you don't have to fool around with a point slope format if you don't want to. All right, I've assigned these examples, but one more thought here before we start working on those. Let's look at these vertical and horizontal lines. Here we have a vertical line. What is the equation? Oh, the alignment's pretty bad on this. What is the equation of this vertical line? Well, vertical and horizontal lines are a special case where one of the two variables drop out. So here, let's first talk about slope here. The slope of a vertical line. Well, the slope is always rise over the run. In this vertical line, the rise is virtually infinite, right? It's going on in both directions, up and down. And the run, there is no run. There is no change in x. So we have infinity divided by 0. And if we cannot divide anything by 0. So we would describe the slope of a vertical line as undefined. And this is something that you need to know. As a side note, why can we not divide by 0? This is a common student misconception. Why can't we? If we just said 10 divided by 2, we know 10 divided by 2 equals 5. And if that's true, then 2 times 5 has to equal 10, okay, to have equality. So let's try something different. If I said 10 divided by 0 equals what number? Okay, well, then we have to turn it around and say what number x times 0 equals 10? What number times x times 0 equals 10? There is no number in existence that we can multiply by 0 and get back 10. Anything multiplied by 0 is 0. So that's why we can never divide by 0. It just doesn't exist. That number just does not exist. So in this case, we would describe this slope then as undefined. Let's go look at this line here then, a horizontal line slope. This horizontal line, rise over the run, has a rise of 0. There's no rise to it. It's a flat line. And the run is infinite. Well, 0 divided by anything is 0. So in this case, a horizontal line has a slope of 0. Now, how do we describe those lines then with these strange slopes. Well, in this case here, a horizontal line is easier to see. Y equals mx plus b. This slope here, m, is 0, so this term just drops out. So the y, really, we're going to describe this line as whatever its y-intercept is here. In this case, it's -3. And if you look on this line, every single point, every infinite point on this line, you could say y equals -3. So that's how we would describe a horizontal line. It will be y equals some real number. And then on the, which I think is a little bit harder to see, on the vertical lines here, you would use the x-intercept. So here our x-intercept is -2, and in fact, everywhere along that line, x equals -2. It doesn't matter where you look at points, every single one of these points on this line, x equals -2. So we would describe a vertical line as x equals some kind of real number. Hopefully that's clear. All right, let's look at some examples. Write an equation in slope-intercept form of the line with a slope of 6 and a y-intercept of -3, then graph the line. So pretty easy here. Y equals mx plus b. We know that m is, we're told, 6, and the y-intercept is -3. So I could write that as 6x plus a -3 if I wanted to, or I could just write -3. So if we have a y-intercept of -3, we would be right here. So we know our lines cross in here at -3. And we kind of use that as an anchor point to graph. I know that the slope is 6/1, so the rise is 6. You're going to count up 6. 1, 2, 3, 4, 5, 6, and the run is 1. So I'm just going to put this right here. And I don't really have a ruler here on my iPad. Hopefully my sketch is going to be okay. But I'm going to go through those 2 points with my ruler in a little bit more accuracy than what I'm able to do sketching here with my stylus. All right, write an equation in point slope form. So this is a little bit different, and this is the one that a lot of people don't have too much experience with. So the formula says y minus y1 equals the slope times x minus x1. So I can just substitute in my slope and the 1 point values that I know of. So here is x1 and here is y1. So y minus 8 equals the slope -3/5 times x minus a -10. So be careful with the signs. Minus a -10. So y minus 8 equals -3/5 x plus 10. Okay, now don't go bother in rearranging this into the format that you're comfortable with. You could still graph as is. We know that our line goes through this point, -10, 8. So go find it. -10, 8 is right here. And you're going to use that as your anchor again. So here, our slope, -3/5. Well, think of that sign always as going with the rise. Okay, so that sign goes up on the top. So in this context, this negative means we're going down 3. We're not rising, we're actually going down. So we're going to count 1, 2, 3, and then our run is 5. 1, oh, actually these are going by 2, so you have to be careful of that. So 1, actually 2, 3, okay, because the scale is by 2s. I hope you guys caught that. And then go over 5. 2, 4, 5. So we're right in here, right in off the grid, but hopefully you can see it's right in the middle. And you are going to connect your lines, and the line goes on and on forever with arrows. Write an equation in point slope form of the line whose slope is 1/3 and contains the following point. Again, y minus y1 equals the slope times x minus x1. And this is x1, and that's y1. So we've got y minus a -3. So when we subtract a negative, take away a negative, that means we're going positive. And we have our slope And, whoops, I should have put our slope there since I know what it is. It's 1/3. And x minus 6. And there we have it. Write an equation in slope-intercept form of a line containing these 2 points. So we know that's y equals mx plus b. Let's first get our slope. So we know our slope is rise over the run. And we know that that's the change in y coordinates over the change in x coordinates. And we're just going to subtract. So we have 9. We might as well label these here. We're going to call this, let's call this x2, y2. We'll call this x1, y1, just to be clear. So we've got 0 minus 9. And we've got -2 minus 4. I'm running out of room. So I have slope equals -9 over -6. A negative divided by a negative is a positive. Just clean this up a little bit. And you might as well reduce. So both are divisible by 3. So we have a slope of 3/2. Let's go ahead and substitute that in. We know our slope is 3/2. Now how do we get the y-intercept b? Well, you can substitute in either of these points. Either one are going to give you the answer that you're looking for. My eyes, let's see, I guess I would, let's use this, doesn't matter. I'm going to use this one, but it doesn't matter. So y equals 9, I'm substituting that in. 3/2 times an x of 4. Now I have only one unknown. So I have 9, and I'm running out of room. 9 equals, well, 4 divided by 2 is 2. And 2 times 3 here is 6. Hopefully you can see that b equals 3. I'm skipping some steps just because I'm running out of room. So bringing it all together then, y equals 3/2 x. Oh boy, I regret doing this in the classroom. That movie is so loud. Y equals 3/2 times x plus 3. Write an equation in slope-intercept form for a line perpendicular to the line y equals 1/5 x plus 2. And this particular line that we're looking for also goes through point 20. All right, well, we know our slope of this line is 1/5. And if there's a line that we're looking for that's perpendicular to that, then we need the negative reciprocal. Or some of us were saying in class, opposite reciprocal. That's an I. So the opposite reciprocal of positive 1/5 is going to give us a slope of -5. So we know this so far. We know our slope of this line we're looking for is -5. That's all we know. We need its y-intercept. Again, we need a point to plug in here to substitute in for x and y so that we can solve for that y-intercept. And here it is. Here's our point. So we've got x and y that we're going to substitute in. So I've got 0 in here for y times -5, and I'm going to substitute in 2 here for x. 0 equals -10. Whoopsie daisy. I got to put plus y. Sorry, plus b. So we've got -10 plus b, and if I solve for b, b is going to equal +10. So if I bring it all together, I've got y equals -5x plus 10 is the equation of our perpendicular line. Okay, I'm now at home, so I no longer have all the noise in my classroom. Hopefully it'll be quiet here. However, I do have dogs, so they can start barking at any moment. So the last two problems, rental costs, very common problems that are modeled with linear functions. First one, we have $525 rent per month plus an annual maintenance fee, pretty common for a condo or for an apartment. Write an equation to represent the total first year's cost A for our months of rent. Well, First, let's go with what's comfortable for us. Y equals mx plus b. And hopefully that when you start to see something per month, and you know that per month would indicate multiplication, that we're going to start to look at that rental cost, $525 per month, being our slope, since it is a constant rate, if you will, dollars per month. What will be the x-axis? What will be on that scale? Well, hopefully you can understand or maybe sketch out something where the x-axis is often almost always time in many real situations. So it looks like we're going to be having months here as our unit. And then over here on the y-axis, we're looking at costs. All right, so they said write an equation to represent the first year's cost A. So instead of having y be used for our dependent variable, we're going to have A for our cost. There goes the dog. And we're going to put in here our monthly rate here, which is $525. And we're going to multiply that by our numbers of months here. And then we have $750 annual fee put on top of those costs. So that's an equation that would represent the first year's costs. And the reason why this is the first year's cost is because we have our y-intercept here, $750. That's on an annual basis. So that $750 would have to have another multiplier if we were to look at years, for instance. So hopefully you can see that. And this is very often the case where some kind of fixed fee, whether it be a gym membership or this type of thing, this is very common in real life that you have a fixed fee and then you have some kind of variable fee, like here, the monthly rent. In the context of a linear function, the fixed fee is almost always the y-intercept. And that's quite a common question on the MCAS at the end of the year. Okay, last one. Rental costs. A car rental company charges $25 per day plus $100 deposit. Compare this rental cost to a company which charges $50 deposit but $35 per day use. If a person expects to rent a car for 9 days, which company offers the better rate? Well, this is a very common real-life scenario. You have to look at this for cell phone packages that different carriers offer. You have to look at this at gym memberships. We often have to look at different pricing schemes and determine which one is the best for you. And there's no right or wrong answer. It really depends on how much you're going to use that phone or the data, how much you're going to use the gym. This is very common in life that you have to look at these two things. I like to set up a table for this. So that's how I like to do it. So let's look at Company A, let's call it. So Company A charges I'm going to go back to my y equals mx plus b. So they charge $25 per day. So hopefully you can see that that's going to be our constant slope. Instead of using x as the independent, I'm going to just say per day. And the deposit is $100. So that's going to be like our fixed fee above. And instead of using the y variable for the dependent, I'm just going to turn that into cost. So that is Company A. Now let's look at Company B. Company B, cost-wise, has a $50 deposit, so a smaller deposit up front, which is always a good thing, but they charge more per day. Oops, I don't want 25. I want 35 per each day. So here are two equations that compares the two companies, and we're asked to figure out which one is better for 9 days. Well, let's first look at something called break-even. Break-even is a term that we would use where we would set the two equal to each other and look at number of days. So if we look at that, I'm going to put the 25 times days plus 100 deposit equal to 35 times day plus the 50. Let's see how many days that they would be identical. So we're going to solve for D. I'm going to subtract 50 from both sides. And I have 25 days plus 50 equals 35 days. And I'm going to subtract 25 days from both sides. And I have a cancel there, and 50 comes down equals 10 days. And I'm going to divide both sides by 10. And I get D equals 5. So what does that mean? If we were going to go ahead and rent for exactly 5 days, well, it wouldn't matter. Between company A and company B, they're identical. So let's take a look at what happens if we charge more, or we actually rent more days. So if we rent more days, I'd like you to make a theory or make a guess before you actually do the math. Do you think if we rented for more days than 5, that the company who charges less per day would be the better bet, or the company who charges more per day would be the better bet? Well, I think it would be easy to guess, make an educated guess, that if we're going to rent for more than that break-even 5 days, that you want to go with the company that has the least daily rental. So let's take a look at what that looks like. We would have 25 times 9 days plus 100, and that would be 225 plus 100. So you're looking at a total cost here of $325, which is a lot, but I guess it's not so bad for 9 days for company A. Now let's look at company B for 9 days. I think you can imagine what's going to happen here. 9 times 35 is 315 plus 50. And that's going to turn out to be $365. And what do you know? It looks like company A is the better bet. Hope this helps everyone. Please subscribe. Take care.